Hi everyone and welcome to lesson 2.2. Today we are going to talk about the converse of our theorems and how we can prove lines are actually parallel and not be given that they're parallel. So far what we have talked about is, hey, if I have these parallel lines, then this happens. Well, what if we are trying to prove that the lines are parallel? That's where the converse comes in. Reminder, the converse is when we go from being if P then Q to if Q then P. So basically what we're saying on each of these is, for instance, with the converse of the corresponding angles theorem, if our corresponding angles are congruent, then the lines are parallel. Same thing then with the converse of the alternate interior angles theorem. If our alternate interior angles are congruent, then our lines are parallel. Same side interior, the converse of that. If our same side interior or exterior angles for that matter are supplementary, then we know the lines are parallel. And then last but not least, converse of the alternate exterior angles. If the alternate exterior angles are congruent, then those lines are parallel. So we're taking basically some of the theorems we've been talking about. Once we know lines are parallel, we flipped it around so that we now know it's true the reverse way. Side note, some things that are never going to prove that, even though they are true, never used to prove, are vertical angles and linear pairs, because while that's happening, they are not actually involving two different lines, just one line. So the other ones can be used to prove, but these are going to be just used when we are talking about when the lines are for sure parallel. All right, so let's look at some examples. So for instance, if we want to make sure that the measure of this angle will make these lines parallel, well, first of all, we want to look, okay, 128 and the question mark, these are an example of corresponding angles. And we know that our angles must be congruent in order for the lines to be parallel. So the question mark would also have to be 128. In letter B, in order for U and V to be parallel, these are same side interior. So we know these angles would have to be supplementary. So 180 minus 126, we know that this would have to be a 54-degree angle in order for them to be parallel. Try letter C on your own. And then be careful with letter D. Oops, lost that in there. Letter D, these are vertical angles. And again, just like we talked about on the last page, vertical angles, that's only involving line U right here. We don't know anything about line V. So vertical angles do not prove our line possible. So this is a not possible situation. Again, vertical angles do not prove lines parallel. So the not possible on this one would be our final answer. Right now, we can also solve for a value of x that will make our lines parallel. Again, if we look at 120 and 3x, these are same side exterior angles. So we know they would have to be supplementary in order for those lines to be parallel. So 3x plus 120 would need to equal 180. We would subtract 120 from both sides. 3x equals 60. So x would have to equal 20 in order for these lines to be parallel. Now, careful on number 3, we are given these angles here. Again, there's no direct relationship between these two. They're not corresponding. One's on the exterior, one's on the interior. But what we could say is, for instance, I know x plus 5 would be the measure of this angle out here because these are vertical. And then now these are same side exterior angles. So again, we know that these would have to add up to equal 180 in order to actually find our value of x. So condense first, 3x plus 1x, we have 4x's, negative 7, but plus 5 is negative 2. Add 2 to both sides. We get 4x equals 182. And when we divide by 4, we get a decimal, but that's okay, 45.5. All right, try the next two on your own. You're using these alternate interior angles to help prove the line's parallel, and then the same side interior. All right, last piece to talk about then today. We aren't going to do many examples, but we will look more in class. But if two lines are parallel to the same line, then we know that they are parallel to each other. So for instance, if I know A is parallel to C and C is also going to be parallel to B, because A and B are both parallel to the same line, they have to be parallel to each other. Or if same idea with perpendicular, I know that if A is perpendicular to C and B is perpendicular to C, these lines end up being parallel to each other, because you can even look like these corresponding angles would be congruent. They're both 90 degrees, so our lines would then be parallel. And we'll see more examples of those when we work in class. Thanks everyone for watching. We'll talk in class.